Okay, let us all stand as we ask for the blessing and guidance of our Lord. May I ask Kathleen to lead us in a prayer.
Tayo pong lahat ay bukat manalangin, Panginoon. Maraming salamat po sa araw na ito na muli yung pinagkaloob sa amin. Nagpapasalamat po kami sa pagkakataong ito na kami muli ay magkakatipon-tipon sa muling pag-aaral, Panginoon. Nawa sa araw na ito, ikaw ang siyang magbigay sa amin ng sapat na katalinuhan at kalakasan at nawa. Ikaw ang siyang maging sentro ng aming pag-aaral, Panginoon. At nawa magkaroon kami ng kaalaman mula dito. Ito lamang po ang aming samo at dalangin sa pangalan ni Jesus. Amen.
Amen. So, good morning, class. It's nice to see you.
Good morning, sir. It's nice to see you too.
So, how is everyone today?
Our day starts well, sir.
Oh, good to hear that from you. Now, is there any absent from our class today?
None, sir.
Before we proceed to our discussion, let's have first a short review about the discussion yesterday. So, what did we discuss yesterday?
Sir, it is about the introduction in algebra.
Okay, correct. Now, would you please define what algebra is?
Algebra is the study of mathematical symbols and the rules of manipulating these symbols.
Okay, very good. Now, how did algebra start?
The roots of algebra can be traced to the ancient Babylonians who developed an advanced arithmetical system with which they were able to do calculations in an algorithmic fashion.
That's definitely correct. Now, who is the father of algebra?
The father of algebra is Al-Khwarizmi.
Very good. Now, why is algebra important?
It is important because it is applicable to other subjects like chemistry, biology, etc.
Okay, correct. Next, why is algebra important in the real world?
Because it is part of history.
Excellent, class. Do you still have any questions regarding our previous topic?
None, sir.
Okay, if none, let us now proceed to our first topic under algebra. For those who are in the back, you may occupy the vacant seats in front. Now I'm going to group you into 3 groups, so you may start counting 1 to 3. Let's start in front.
Okay, sir. 1, 2, 3. 1, 2, 3. 1, 2, 3.
Okay, now you may go to your groups. Where's the group 1?
We are here, sir.
The group 2?
We are here, sir.
And the group 3?
We are here, sir.
Since you are now with your respective groups, I will now explain the mechanics, so please listen carefully. I will show 4 pictures of a number, and you will just guess or identify whether it is an integer or not. Is it clear?
Yes, sir.
Okay, let's start. So the first number is 0. Is 0 an integer or not?
It is an integer, sir.
Okay, let's see. So correct, 0 is an integer. So next, we have 3. Is 3 an integer or not?
It is an integer, sir.
So let's see. So very good, it is an integer. Next, we have negative 1. Is negative 1 an integer or not?
It is an integer, sir.
Okay, let's see. Yes, it is an integer. So the last, we have 3/5. Is 3/5 an integer or not?
It is not an integer, sir.
Let's see. Yes, you're correct. It is not an integer. So good job, everyone. I see that you really make an advanced reading about our topic for this day, just like what I've told you yesterday. Before we start our discussion, let's have first this time to differentiate the integers from other types of real numbers. So I have here the flowchart of real numbers. So under the real numbers, we have the irrational and rational numbers. And under the rational numbers, we have the integers, which is our focus for this day. The whole numbers and the natural numbers. So first we have the integers. Integers are real numbers that have no decimal. So for example, we have negative 1, 0, and 1. And I have here a number line. The positive numbers and the negative numbers without any fractional part or decimal are considered as an integer, including 0. So next we have the rational numbers. rational numbers are real numbers that can be written as fractions with integers. So for example, we have 1/7 and 3/4. So the condition here is that the numerator should be an integer and the denominator should be a non-zero integer. So 3 is an integer, 4 is a non-zero integer and considered as a rational number. So next we have the irrational numbers. Irrational numbers are real numbers that cannot be written as a simple fraction. So for example, we have the pi, which is approximately 3.14, and another we have the Euler's number and the square root of 2. So all of these three examples has non-terminating and non-repeating decimals, so they are considered as irrational numbers. So next we have the whole numbers. Whole numbers are positive real numbers that have no decimals including 0. So from 0 to positive infinity without any fractional part are considered as whole numbers. So last we have the natural numbers. Natural numbers are real numbers that are no decimal and bigger than 0. So example, we have 1, 2, and 3. So from 1 to positive infinity, those are considered as natural numbers or counting numbers. Since we already know that integers are real numbers with no decimal and fractional part, now let's proceed on working with integers. So under this topic, we have 4 subtopics: the addition, subtraction, multiplication, and division of integers. So first, we have the addition of integers. So this is the rule. When two numbers have the same sign, positive or negative, you will just add them and use the same sign they have. So I have an example here. So first, we have 15 plus 12 is equal to 27. So as you can see, both of them have the sign of positive. So what we're gonna do is just we will add them. 15 plus 12 is equal to 27, and then use the same sign, which is positive. So positive 27. So second, we have negative 14 plus negative 33. So same process, just add them. So 14 plus 33 is 47, and then use the same sign they have, which is negative. So we will have negative 47 as the sum. So next, when two numbers have the different sign, positive and negative, you will subtract them and use the sign of the larger number. So I have here another example. So negative 12 plus 15. So what we're gonna do is just subtract them. So the larger number is always the first. So 15 minus 12 is equal to 3. So after subtracting the two numbers, we will use the sign of the larger number, which is 15. So we'll come up with positive 3. And second one, we have 17 plus negative 25. So same process, the bigger number, and then subtract the smaller number. So 25 minus 17 is 8, and then use the sign of the larger number, which is 25, and its sign is negative, so negative 8. So now let's proceed to subtraction of integers. So this is the rule. Change the operation sign to addition. Change the sign of the number following the operation, then follow the rules of addition. So I have here an example. So negative 2 minus negative 4. So what we're gonna do is just change the operation to addition, and then change the sign of the number following the operation to positive. So after that, we will just add or follow the rules of addition. So negative 2 plus 4 is positive 2 because they have different signs, so we will subtract and then use the sign of the larger number. So we'll have positive 2. Sign of negative 4 is positive. So this will become negative 4. Negative 2 plus negative 4, it will be equal to negative 6 because according to addition rule, if the two numbers have the same sign, we'll just add them and then follow or use the same sign they have. So there. Now let's proceed to multiplication and division of integers. So when two numbers have the same sign, just multiply or divide them, then give the result a positive sign. So I have here an example. So first, under the multiplication, so negative 8 multiplied by negative 4 is equal to 32. And then also, 8 multiplied by 4 is equal to 32. Since the two numbers have the same sign, we will just multiply them and then have the product of positive. And then on the other side, the division, we have 27 divided by 3 is equal to 9, and then negative 27 divided by 3 is equal also to 9. It's just the same process and same rule. So we'll divide them and then because they have the same sign, it will produce a quotient of positive. So when two numbers have different sign, multiply or divide and give the result a negative sign. So another example, we have 8 multiplied by negative 4 is equal to negative 32. So as we can see here, they have different sign, of course, positive and negative. So what we're gonna do, according to the rule, we will just multiply and then give the product a negative sign. So negative 32. And also, same goes to the division. Negative 27 divided by 3 is equal to negative 9, and then 27 divided by negative 3 is negative 9. So same rule applied. They have different sign. So you will divide them and then give the quotient a negative sign. Now let's proceed to PEMDAS rule. So PEMDAS, so P means do operation inside parentheses, and then E, evaluate terms with exponents, MD, do multiplication and division in order from left to right, and then AS, add and subtract terms in order from left to right. So try remembering this rule because you can also apply this as we go further on the lesson. So this is an example of it. So as you can see, we have 18 divided by 6 multiplied by 5 on the parenthesis, minus 14 divided by 7. So according to the PEMDAS rule, we will first solve for or do operation inside the parenthesis. So we will first solve this, 18 divided by 6 multiplied by 5. So 18 divided by 6 is 3 multiplied by 5. And then just bring down the negative 14 and negative 14 divided by 7. So 3 times 5 is equal to 15 minus 14 divided by 7. 15 minus 14 divided by 7. So according to the PEMDAS rule, first is to divide this. So 14 divided by 7 is 2. So 15 minus 2 as the last step on the rule. 15 minus 2 is equal to 13. So that is our topic for this day. Now, do you have any questions or clarifications regarding our discussion?
None, sir.
Good. So I assume that you all understand the lesson that we have discussed today. To further develop your knowledge about integers, let us have a quick recitation about the things we've discussed a while ago. So I will flash some expressions and then you're going to evaluate or solve them. So for number 1, we have 27 plus negative 5. So anyone who can give the answer?
Sir, the answer is positive 22.
Okay, let's see. Okay, correct. Very good. So, number 2, we have negative 15 minus negative 7. So, what's the answer?
Sir, the answer is negative 8.
Okay, let's see. Alright, correct. So, number 3, we have negative 5 multiplied by negative 9 multiplied by negative 2. So, anyone who can give the answer? Yes.
Sir, the answer is negative 90.
So, let's see. So, correct. Very good. So, number 4, we have negative 15 divided by 3. So, anyone who can give the answer? Yes?
Sir, the answer is negative 5.
Okay, let's see. Alright, very good. So for that, let's give ourselves a victory clap for a job well done. On the count of 3. 1, 2, 3. Victory! So before we end our discussion, let me ask you this question. Do you find our discussion interesting and fun?
Yes,
Why?
because we have discovered a lot of new things about integers.
Although we sometimes don't want to study mathematics, particularly integers, we cannot deny the fact that it has also its uses in real life situations. For example, on business, if there's profit, there's positive numbers. If there is loss, there is negative numbers. This just proves that mathematics is also useful on our lives. It is not just a simple subject that after you learn from it, you will put it to trash. We must apply all of what we have learned in this subject or in this topic on our daily lives. So this time, please bring out a 1 sheet of paper and answer this as your activity for this day. Get one and pass. So class, please pass your papers. Thank you. So for your assignment, please copy this. Are you done?
Yes, sir.
Alright. So that's all for today. I hope you've learned something from what we have discussed. So thank you and see you tomorrow.